So to do this problem, let's look at standard form for a circle. Where h comma k, that's the center, and then r is the radius. So we want to be able to take this and put it in this form. That way we can identify the center and the radius of the circle, and then it'll be way easier to graph. So before we do that, we need an x minus something squared parentheses. So to make that happen, we've got to be able to factor the x terms, so that comes out to be one of those, to come out to be a perfect square trinomial. So to make that happen, let's take the x terms and let's write them next to each other, because the order you add things in doesn't matter. Let's say x squared plus 8x, and I'm going to put a plus blank here, because I want to find out what that term is to make it factor to be a perfect square. And then we'll put the y terms together, plus y squared minus 6y plus a blank. That all equals 0. So we want to be able to fill in some numbers there that are going to make us factor perfectly. And to factor so that you have a perfect square, it's a quick process. You take the b of like if it was in standard form of a quadratic, meaning the number that's a coefficient of x. You divide it by 2, and then you square the result. So 8 divided by 2 gives you 4. 4 squared gives you 16. That's what I need to add to this side. Because now if you factor that trinomial, you'll get x plus 4, which is x plus 4 squared. So it turned out exactly what we wanted to have, an x plus or x minus something being squared. So we got to do the same thing with this in blue over here. You've got to put a number in here so that when you factor it, it comes out to be a perfect square. And you find that by taking the middle number, the number attached to the variable of the first power, divided by 2, so we get negative 3, and square that result. Negative 3 squared gives us positive 9. Because now if you factor that, oops, that's not an x, it's a y right now. If you factor that, you get y minus 3, which is y minus 3 squared. Okay, and this is just the check work, just to make sure everything turned out right. So we got a plus 16, a plus 9 to this side. That allowed us so that when we factor it, everything's going to come out nicely. But we want to remember that we got to keep an equation balanced. If you add 25 things to the left side, you've got to add 25 things to the right side. And now it's balanced. So let's see what we're dealing with right now. We'll write it out as one big equation. Here's what it looks like, and then we factor, like we said, factor the x terms. You get x plus 4 squared. And then the y terms, and you factor, you get y minus 3 squared. And then we have 25 over here. So it's getting closer to that standard form. Getting closer, but the form says it's supposed to be x minus h. So I can fix that by just saying it's minus a negative 4 in here. Because that's the same thing, right? Minus a negative is the same thing as adding 4. And then y minus 3, that's already all set because we have the minus sign just like the formula says you're supposed to have in the y terms. But it's supposed to be r squared. So instead of 25, I'm going to write its equivalent of 5 squared. And so now everything's looking like the standard form of the circle. Now we can identify the center. The center is negative 4 comma 3, because this is my h, this is my k. And the radius is 5. It's always the number being squared on that outside. So there we have that the center of the circle is negative 4 comma 3, and that has a radius of 5, and that's enough to graph too. There we are at negative 4 comma 3 for a center, and we're 1, 2, 3, 4, 5 spaces for a radius. So that means if we go 5 spaces to the right, 1, 2, 3, 4, 5 spaces down, 5 spaces to the left, should be touching all those points, because that would give us 5 units from the center, which is the definition of a radius. 5 up, 5 to the right, 5 down, 5 left. There we go. There's a rough sketch of our graph.